Hello friend. Now today I am going to take some more example on adjoint of a matrix. Now see, last time we have seen the definition cofactor of an element. Now see what is the definition of cofactor of an element. Cofactor of an element, it is denoted by the notation capital Aij. See what is the definition of cofactor of an element. Cofactor of an element small Aij, it is denoted by the notation capital Aij and it is given by the formula -1 raised to I plus j into Mij. Mij means that is minor or that is the determinant. So see what is the definition of cofactor of an element. Cofactor of an element small Aij, it is denoted by the notation capital Aij and it is given by the formula -1 raised to, just take the addition of these suffixes I plus j into Mij. So see, in case of 3x3 matrices or in case of 3x3 matrix, there are in all 9 cofactor element. For the first row it is A11, A12, A13. For second row it is A21, A22, A23 and for third row it is A31, A32, A33. In case of 3x3 matrix, in all there are 9 cofactor element. In 2x2 matrix, obviously there are 4 cofactor element, A11, A12, for second row it is A21 and A22. So see, the cofactor of an element, it is denoted by the capital notation, it is denoted by capital Aij and this is given by this required formula. Now see, if this is suppose the matrix of cofactor, then how to write the adjoint? Adjoint of matrix, it is denoted by the notation Adj of capital A. This is the notation for adjoint of matrix A. If this is suppose the matrix of cofactor, then how to write the adjoint of A? Adjoint of A means transpose of matrix of cofactor. How to write the transpose? Transpose means write this first row as a first column, write second row as a second column and write third row as a third column. So this is called the adjoint of A. So see, there are two definitions. Cofactor of an element, it is given by the notation capital Aij and that is equal to -1 raised to I plus j into Mij. It is the formula for finding the cofactor of an element. In case of 3x3 matrix, there are in all 9 cofactor element. And if suppose this is the matrix of cofactor, then how to write the adjoint A? Adjoint A means just take its transpose. Transpose means write first row as a first column, second row as a second column, third row as a third column. It is called the adjoint of a matrix. Now see what is the given example. If A is equal to -1, -2, -2, 2, 1, -2, 2, -2, 1, then the question is, show that adjoint of A is equal to 3 into A transpose. A dash, it is the notation for transpose. So this is the example. From the given matrix A, first of all find out this adjoint of A and show that that is equal to 3 into A transpose. So write down the solution. So this is the given matrix. So write down the given matrix. Let A is equal to -1, -2, -2, 2, 1, minus 2, 2, minus 2, 1. Now see how to find out the adjoint of a matrix. Now this is some different method for finding the adjoint of matrix. So write down this method. There are just 3 steps. So write down the step number 1. This is the first step. Therefore, matrix of minor is equal to, now from the given matrix A, we want to find out this matrix of minor. Now see how to get this matrix of minor. First of all, find out this first minor element. So this is the position of first minor element. So for first minor element, what is the process? Delete corresponding row and corresponding column and take the determinant of the remaining element. See how to get this minor element. For the first minor element, what is the process? Delete corresponding row and corresponding column and take the determinant of the remaining element. So this is 1 minus this product 4. So 1 minus 4, so this is minus 3. Find out this next minor element. So this is the element. So for this element, this is the corresponding row and this is corresponding column. So delete corresponding row, corresponding column and take the determinant 2 minus and minus plus 4. So 2 plus 4, it is 6. Now this is the next element. For the next element, delete corresponding row, corresponding column and take the determinant minus 4 minus 2. This is minus 6. Now find out this next minor element. So for this element, delete this row and delete corresponding column and take the determinant of the remaining element. So minus 2 and minus plus 4. Minus 2 plus 4. So this is the element. Delete corresponding row, corresponding column and take the determinant minus 2 and minus 4. So this is minus 6. For the middle element, delete corresponding row, corresponding column and take the determinant minus 1 and plus 4. So this is 3. Find out this next binary element. So delete corresponding row, corresponding column 2 plus 4. So this is 6. Find out the next binary element. So delete corresponding row, corresponding column and take the determinant this 4 and minus of minus plus 2, 4 plus 2, it is 6. Find out this next element. Delete row and column 2 and plus 4, it is 6. Find out this next minor element. So delete corresponding row and corresponding column and take the determinant of the remaining element. So minus 1 and minus minus plus 4. So this is minus 4 plus 4. So this is 3. For this last element, just delete this row and column. Minus 1 and minus minus plus 4. It is 3. So say this is the first step. From the given matrix A, first of all find out this matrix of minor. Now what is the second step? From matrix of minor, find out the matrix of cofactor. So see how to get the matrix of cofactor. Just change the sign of these 4 elements. It is the matrix of cofactor. So first element as it is minus 3, change the sign means it is minus 6. This element this is as it is, change the sign means it is 6. 3, change the sign means it is minus 6. As it is, change the sign means it is minus 6 and as it is. So this is the matrix of cofactor. So see how to get the matrix of cofactor. If this is the matrix of minor, then how to get the matrix of cofactor? Just change the sign of these 4 elements. It is the matrix of cofactor. Now from matrix of cofactor, now write the adjoint of given matrix. So this is the notation for adjoint ADJ of matrix A. That is called the adjoint of A. So what is the adjoint of matrix? If this is the matrix of cofactor, then how to get the adjoint? Just take its transpose. Transpose means write first row as a first column, write second row as a second column, and third row as a third column. So this is our left hand side. It is equation number 1. So see, what is the question? Our question is, show that adjoint of A is equal to 3A dash. So adjoint of A, that is our left hand side, that is suppose equation number 1. Now find out right hand side, which is 3 into A dash. So write down now 3 into A transpose, this is equal to 3. Now this is a matrix, say A transpose, dash means it is the transpose. Transpose means write first row as a first column, write second row as a second column, and third row as a third column. So this is equal to, just multiply by 3. This is minus 3, 6, 6. This is minus 6, 3, minus 6. This is minus 6, minus 6, 3. So this is suppose equation number 2, that is our right hand side. So from equation 1 and 2, we can observe that adjoint of A equal to 3A dash, that is the required answer. Now say this is the second example. If A is equal to matrix 1 0 1 2 1 1 0 1 2, then the question is, show that adjoint of 2A is equal to 2 square into adjoint of A. Now this is the solution and this is the given matrix. So write down the given matrix. Let A is equal to matrix 1 0 1 2 1 1 0 1 2. Now first we find out this right hand side, which is 2 square into adjoint of A. So first of all, from the given matrix A, first of all we find the adjoint of matrix A. So again there are 3 steps how to find out the adjoint of A. From the given matrix A, first of all find out the matrix of minor. This is the first step. From matrix of minor, find out this matrix of cofactor, and finally find out this adjoint of A. There are just 3 steps. From the given matrix A, find out the matrix of minor. From matrix of minor, find out the matrix of cofactor, and from matrix of cofactor we can get this adjoint of A. So write down this. Therefore matrix of minor is equal to matrix. Now find out this first minor element. So for this element, delete corresponding row and corresponding column and take the determinant of the remaining element. 2 minus 1, so this is 1. Find out this next minor element. So delete corresponding row, corresponding column. 4 minus 0, so this is 4. For the next element, delete row and column and take the determinant. 2 minus 0, so this is 2. Find out this next minor element. So this is the corresponding position of the element. So delete corresponding row and corresponding column and take the determinant. 0 minus 1, so this is minus 1. Find out the middle element. So delete corresponding row, corresponding column. 2 minus 0, so this is 2. Find out next element, delete corresponding row, corresponding column. 1 minus 0, this is 1. For the next element, delete row and column and take the determinant. 0 minus 1, so this is minus 1. For the next element, delete this row and column and take the determinant. 1 minus 2, so this is minus 1. For the last element, delete this row and delete this column and take the determinant of the remaining element. 1 minus 0, so this is 1. So this is the process for finding the matrix of minor. Now from matrix of minor, we have to find out the matrix of cofactor. So matrix of cofactor is equal to, So how to get this matrix of cofactor? Just change the sign of these 4 elements. So write down this first element as it is. Change the sign means it is -4. This element as it is, change the sign means it is 1. As it is, change the sign means it is -1. As it is means -1. Change the sign means +1. As it is means just write down 1 as it is. So this is our matrix of cofactor. How to get the matrix of cofactor from matrix of minor? Just change the sign of these 4 elements. Now from matrix of cofactor, we have to write this adjoint of A. So what is adjoint of A? Transpose of matrix of cofactor, it is called adjoint. So how to write the transpose? Transpose means write first row as a first column, write second row as a second column, write third row as a third column. So this is adjoint of A. So see how to get the adjoint of matrix from the given matrix. There are just 3 steps. Find out the matrix of minor. From matrix of minor, find out this matrix of cofactor, and from matrix of cofactor, just find out its transpose. It is called the adjoint. Now that is the right hand side. So find out this term. Therefore, 2 square into adjoint A. 2 square means 4, and put this value for adjoint A. Adjoint A means 1, 1, -1, -4, 2, 1, 2, -1, 1. So just multiply by 4. So this is the final answer. Multiply by 4 means it is 4, 4, -4, -16, 8, 4, 8, -4, 4. So this is our equation number 1. That is our right hand side. So this is our required right hand side. It is 2 square into adjoint A. Its value is given by this equation number 1. Now find out this left hand side, which is adjoint of 2A. So first of all, from given matrix A, first of all write adjoint. First of all write 2A, and from the matrix 2A we can find the adjoint of 2A. So this is matrix A. So from matrix A, first of all find out this 2A. So multiply this given matrix suppose by 2. So this will be 2, 0, 2, 4, 2, 2, 0, 2, 4. Now this is our given matrix 2A. Now from matrix 2A, now find out its adjoint. So again there are 3 steps. From this matrix 2A, first of all find out matrix of minor, then find out matrix of cofactor, and then take its transpose. So write down the matrix of minor. Therefore, matrix of minor is equal to, now find out this first minor element. So this is the corresponding position of the element. Delete corresponding row at corresponding column and take the determinant of the remaining element. 8 minus 4, so this is 4. Find out next element. So delete corresponding row and column. 16 minus 0, so this will be 16. Find out next minor element. So this is the corresponding element. Delete this row and delete this column. 8 minus 0, so this is 8. Find out this next minor element. So delete corresponding row, corresponding column. 0 minus 4, so this is minus 4. Find out this middle element, delete this row and column. 8 minus 0, so this is 8. Find out the next element, delete this row and column. 4 minus 0, so this is 4. Find out next element, delete row and column. 0 minus 4, so this is minus 4. Find out this next element, delete this corresponding row and corresponding column and take the determinant. 4 minus 8, so this is minus 4. Find out the last element, delete this column and delete this row and column, and take the determinant of the remaining element. 4 minus 0, so this is 4. So say this is the process for finding the matrix of minor. Just delete corresponding row and corresponding column and take the determinant of the remaining element. Now from matrix of minor, this is the next step, find out matrix of cofactor. How to get the matrix of cofactor? Just change the sign of these four elements. So write down this first element as it is, change the sign means minus 16, as it is, change the sign means 4, as it is, change the sign means it is minus 4, as it is, change the sign means 4, and as it is means it is 4. Now if this is matrix of cofactor, then we have to write the adjoint of 2A. So write down here, therefore, adjoint of this matrix 2A is equal to, so how to write the matrix, how to write the adjoint? If this is the matrix of cofactor, then adjoint means transpose of matrix of cofactor. So just take its transpose. Transpose means write first row as a first column, write second row as a second column, and write third row as a third column. So this is our equation 2. So from equation 1 and 2, we can easily observe that this is the first row 4, 4 minus 4. This is the second row minus 16, 8, 4. And this is the third row 8 minus 4, 4. They are the same. So we can conclude that the adjoint of 2A, this is same as 2 square into adjoint of A. Now let us take third example on the same topic, which is adjoint of A. If A is equal to matrix 1 to 4, 7 to 0, 0, 1, 2, then the question is, show that the product of A and adjoint A, show that it is same as determinant A into R. So write down the given matrix. Let A is equal to matrix 1 to 4, 7 to 0, 0, 1, 2. Now what is given left hand side? We are given left hand side as A into adjoint of A. So we want to find out this product A with adjoint of A. So first of all we find this adjoint of A. So this is the same process from matrix A. First of all find out this matrix of minor. So this is equal to, so same thing, first of all find out this first minor element. So delete corresponding row and corresponding column and take the determinant of the remaining element. 4 minus 0, this is 4. Find out this next minor element. So this is the position of the corresponding element. Delete corresponding column and corresponding row. 14 minus 0, so this is 14. Find out next element. So this is the corresponding position. Delete corresponding row and corresponding column. 7 minus 0, so this is 7. Find out this next minor element. So delete corresponding row, corresponding column and take the determinant of the remaining element. 4 minus 4, so this is 0. Find out this middle element. Delete row and column. 2 minus 0, this is 2. Delete next element, delete row and column and take the determinant. 1 minus 0, so this is 1. Find out this next minor element, delete corresponding row, corresponding column. 0 minus 8, so this is minus 8. For this element we delete this row and we delete this column and take the determinant. 0 minus 28, so this is minus 28. Take this last element, delete corresponding row, corresponding column. 2 minus 14, this is minus 12. This is the last element, delete this row and delete this column. So 2 minus 14, that is minus 12. So from matrix of minor, this is the next step, find out matrix of cofactor. Matrix of cofactor means just change the sign of these four elements. So this number as it is, change the sign means minus 14. This number as it is, change the sign means 0. This number as it is, change the sign means -1. As it is, change the sign means it is 28, and this number as it is. So from matrix of cofactor, now we have to write the adjoint of given matrix A. Adjoint means transpose of matrix of cofactor. It is called the adjoint of matrix. Transpose means write first row as the first column, write second row as the second column, and third row as a third column. So this is adjoint of A. So see, there are 3 steps for finding the adjoint of given matrix. From the matrix A, suppose we want to find out this matrix of minor, then find out the matrix of cofactor, and finally take its transpose. It is called the adjoint of matrix. Now let us find out this product A into adjoint of E. So write down. Now this is our left hand side. A into adjoint A is equal to now this is our matrix A into adjoint of A. We have found this value 4, 0, minus 8, minus 14 to 28, 7 minus 1 minus 12, that is adjoint of A. So let us find out this product. So this is equal to, now how to find out the product of 2 matrices? Consider first row and first column and take the product of the corresponding element and take their addition. 4 minus 28, so see, this is 4, this minus 28 and plus 28. So we can directly write here 4. So this is the first element, which is 4. First row and second column, take the product of the corresponding element and take their addition. 0 plus 4 minus 4, it is 0. First row and third column, minus 8 plus 56 and minus 48. So this is again 0. Now consider second row. Again consider first column, second column and third column. This is 28 minus 28 and plus 0. So this will be 0. Second row, second column, 0 plus 4 plus 0. So this is 4. Second row, third column, minus 56 plus 56 plus 0. So this will be 0. Now consider third column. 0 minus 14 plus 14, this is 0. 0 plus 2 minus 2, this is 0. 0, 28 minus 24, so this will be 4. So this is our equation number 1. So this is our left hand side. Now what is right hand side? Right hand side will be determinant A into I. So first of all, find out determinant A. So right here now, determinant A is equal to determinant A means this matrix 1 to 4, 7 to 0, 0, 1, 2. So find out this value determinant A. Just consider this first element, delete corresponding row and column and take the determinant. 4 minus 0, so this is 4. For the middle term, we take the minus sign, minus 2 into bracket, delete corresponding row and column, 14 minus 0, so this is 14, plus 4 into bracket, delete row and column and take the determinant, 7 minus 0, so this is 7. So what is determinant A? 4 minus 28 plus 28, so value of determinant of A equal to 4. So this is our right hand side, therefore determinant A into I is equal to, what is the value for determinant A? It is 4, and I means the unit matrix of order 3. So this is 1 0 0 0 1 0 0 0 1. So So now find out this product, just multiply by 4. This is 4, 0, 0, 0, 4, 0, 0, 0, 4. So this is our equation number 2. That is our right hand side. So from equation 1 and 2 we can observe that this left hand side A into adjoint A, it has the same value that determinant A into R. So from equation 1 and 2, what is the conclusion? A into adjoint A is equal to determinant A into R. So thank you for watching.